Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at solving equations that involve absolute value. They're also known as absolute value equations. The main goal in this video is how do we solve an equation that involves absolute value. So to understand this, there's a few things that we need to go over. So absolute value equations contain at least one absolute value expression. The simplest form of an absolute value equation is the absolute value of x equals n. So this is something that we started evaluating back in 6th grade when we were first introduced to that concept of absolute value, right? So absolute value, again, is a distance. And so we have to consider the case where the solution is x units from 0 in the negative direction and the case where the solution is x units from 0 in the positive direction. Because remember, when we take the absolute value of like 4, right? That's going to be a positive 4 because it's, again, 4 units away from 0. And if we take the absolute value of like negative 4, that is also 4. So we have these two cases that we have to make sure we're keeping in mind as we go through and solve these absolute value equations. And so down here in this table, it pretty much just sums up what we just talked about, and especially looking down at the example here, right? If we have this absolute value of d equals 3, that means d either has to be 3 or d has to be negative 3. So we have to consider both of those options as we go through and solve these different absolute value equations. So let's get started with looking at the first example. In this one, it says we're going to solve an absolute value equation when n is greater than 0. So n is what they're referring to on the right-hand side of the equal sign. It's that number that's all by itself. All of these are positive values that are on the right-hand side of the equal sign. We're going to see what happens when that's not the case in the next example. So to start, again, we have to consider both cases, right? So in this case, that means this y plus 2 could be equal to 4, or we might have the situation where this y plus 2 is equal to a negative 4. And now we just go through and solve each of these little one-step equations. So we're going to subtract 2 on this one, and we'll get y equals 2. Or we could have, in this case, this y plus 2 equals negative 4. We actually are going to subtract 2 in this one as well to solve for y, and we'll get y equals negative 6. Before we graph our solution set, we can double check that these are actually going to make this equation true. Again, we talked about this in a lot of other videos about how with equations, it's really important to just take that time, especially on an assessment, to double check that what you came up with for your answers, or in this case answers, that it makes this equation true. So if we test it, the absolute value of 2 plus 2, is that going to equal 4? Well, 2 plus 2, that's going to be 4. So the absolute value of 4 is 4, and we know that is for sure true, right? So this is going to work. And if we check the other one, the absolute value of negative 6 plus 2, and again, does this equal 4? We're going to get the absolute value of negative 4, and the absolute value of negative 4 is 4, and so this turns out to be true as well. And to graph these, all we're going to do is we're going to take what we have for our two answers, so y equals 2. We're going to put a point on that spot on our graph. And then we're going to say, okay, the other one is y equals negative 6. We're going to put a point on that side of our graph. And then we can even go and write our solution set. So we can use a set notation. And then we can write negative 6 and 2 as our two solutions for this absolute value equation. And now we're going to do the same thing on this second problem that's on this slide. Graph the solution set of the absolute value of 2t minus 4 equals 8. Again, we just need to consider that there are two possible cases where t could be positive or negative. And so we're going to say, all right, well, if we have 2t minus 4 equals the 8, or we might have the case where 2t minus 4 equals a negative 8. And then we go through and solve using our inverse operations that we've been using for quite some time now. We're going to add 4 to both sides on this left side here with this equation here. That's over on the left side of this problem. And so then we're going to have 2t equals 12. And then my last step is to divide by 2. And so we find that t is equal to 6. Or we might have the case here, so we're going to add 4. So this 2t minus 4 equals negative 8. We're going to add 4 to both sides, just like we did on the other equation there. And then we're going to have 2t equals a negative 4. And then the last step is to divide by 2. So divide by 2, and we get t equals negative 2. Again, we can check our solution just to make sure that this does actually check out by taking, again, what we found for each of our variables and plugging it back into the original equation. So we're going to have this absolute value of 2 times 6 minus 4. Again, we're asking ourselves, does that equal 8? So we're going to have the absolute value of 12 minus 4. And so we get the absolute value of 8. And we know that that's going to be true, right? So the absolute value of 8 is 8. And then if we check the other side, we're going to have the absolute value of 2 times negative 2 minus 4. And again, we're asking, does that equal 8? Going back to our, again, original absolute value equation. So 2 times negative 2, that's going to be a negative 4. So we'll have negative 4 minus 4 inside the absolute value symbols. And so absolute value of negative 8, we do know that is equal to 8. So those are my two possible answers, t equals 6 and then t equals negative 2. So to plot our answers here, we're just going to put a dot on each of those values, then you're good to go. Okay, so what happens if we have an absolute value equation when n is less than 0? So in both of these cases that we're seeing on the screen here, we have the absolute value of 3x minus 4 equals, again, a negative value, so n is less than 0. And then we see the same thing with this absolute value equation on the right-hand side. Well, this is trying to tell us that the distance between this 3x and 4 is equal to a negative 1. And distance can't be a negative. So this actually does not have a solution. So we say this is an empty set, a no solution, or a null set. So just to write out what we just said, so this absolute value equation is telling us the distance between 3x and 4 is negative 1. Distance cannot be negative. So this means our answer is the empty, or you call it the null set. So we use that notation like we talked about in another video, right, which is like a 0 with a slash, or you could write that there's no solution. So either of these options here are your final answer. So that's going to happen. So it's really important when you solve absolute value equations that you double check. You know, once you have the absolute value alone on one side of our equation, is the value that's on the other side a positive or a negative? Because if it's 0 or a positive, then you're good to go. But if it's a negative, it's telling us that distance is negative, and that's not going to work, okay? So if we take a look at this one on the right, you don't necessarily have to write everything that I have written in this like orangey red color here, but this is the same situation, right? We have this absolute value of b minus 1 is equal to negative 3. So this is telling us, hey, the difference between b and 1 is a negative 3. That doesn't make sense. And so this is also going to have an answer, just the null set, okay? Or you could put no solution. All right, that's going to be it for this video. That goes over just the basics of solving absolute value equations. Make sure you check out the next one that's going to have some story problems for us to take a look at, where we're going to write and then solve an absolute value equation. Thanks for watching.